All right, we are finally ready to graph the sine and cosine functions and basically graph any sine function and any cosine function, meaning we've already paid attention to the amplitude. Okay, so we know how that works. We found the period using B, and we know how the period affects the graph. But today, our special attention is on midline and phase shift. So phase shift has to do with adding C, or adding or subtracting within the argument. And anytime you add or subtract to the x value within the function, you're going to shift the function left or right. So the phase shift is going to shift me left and right, and that's where the challenge is. That's where most, if there's a struggle to understand or a struggle to find something, it's phase shift. Phase shift can be challenging. Then, when you add d outside of the argument, so when you evaluate the function first and then just add or subtract a number on the outside, you're going to shift the function up or down, and that's going to change the midline. So the midline's pretty basic and pretty easy to find. Okay, so we have amplitude, which is pretty easy conceptually. We have the period, pretty easy to find. We have the midline shifting the graph up or down. It's pretty easy. And then C, phase shift, is going to be a little challenging. Okay, so that's our focus today, midline and phase shift. So just to do a quick recap, we already know how to find the amplitude. Check. We know how to find the period. Check. Phase shift will always be the opposite of the C value divided by B, which is what makes shifting left and right kind of tricky. It's going to be a horizontal shift, so the phase shift. The phase shift numerically is the opposite of C over B. Okay, so in the equation you always change C. And then D on the outside is going to be a vertical translation. D up or D down. The midline will always be a horizontal line of the form y equals whatever the D value is. So that's pretty easy. So if you see plus 5, the line is going to be y equals 5, which is a horizontal line. So that's going to be, I think A is even easier, or D is even easier than A. All right, so that's where we are today. When you're done today, you will be able to graph any sine or cosine function of this form. So here we go. First problem. Find the amplitude, find the period, find the phase shift. Understood, the midline is understood to be just the x-axis, or y equals 0. So we're not really focusing on midline yet. We will in a minute, and then we're going to graph the function. And so there's going to be a little bit more to graphing today than before. All right, so let's find the amplitude. The amplitude, of course, is the absolute value of 3, which is 3. The period, 2 pi over the absolute value of b. So 2 pi over the absolute value of 2, or just pi. Okay. Then phase shift, and we're going to see what in the world is phase shift. PS no longer means postscript in this context. Phase shift is PS. All right, so the phase shift is the opposite of the C value divided by the B value. The opposite of C is negative pi over 2 over the B value, which is 2, which is negative pi over 4. Once again, if you are good at anything when you're done with trig, you're going to be really good at manipulating fractions, operating on fractions. Okay, so now I have all this extra space. Now is when that argument where we take the value that's being plugged into sine and see how it kind of plays out in context. So here's what I mean by that. 3 times sine of something, and the of something initially was between 0 and 2 pi. So now our x values are going to be kind of shifted. So here's what's crazy. Sine used to always go from 0 to something, from 0 to 2 pi initially. Well, now we're shifting the graph left or right. So now we're not starting at 0. So now is when this process becomes really important. So I'm going to solve for x. I'm going to undo plus pi over 2. I'm going to subtract pi over 2. Okay, now what that means is, graphically, we are now shifting 0 left to negative pi over 2, and we're shifting 2 pi left negative pi over 2 spaces. So we're basically taking the original graph and shifting everything to the left pi over 2. 0 minus pi over 2, negative pi over 2. All right, which leaves me 2x less than 2 pi minus pi over 2 is 3 pi over 2. Do a little bit of arithmetic off to the side, and you'll see that, but you're going to get, once again, really good at knowing what those values are. Then, of course, we divide by 2. Now, the dividing by 2 is going to, that's the division part. So because we're dividing by 2, we are cutting the graph in half. Okay, so it's the opposite. So you see plus, it actually goes left. When you see 2x, you divide by 2, it actually shrinks the graph. It compresses the graph. So that gives me negative pi over 4 x, and then 3 pi over 2 divided by 2, 3 pi over 4. So let me explain what these numbers actually mean. When you go through this process and solve for x, the number on the left-hand side of the inequality when you're done will always be the phase shift. That was c, right? So we wound up opposite of c, and then we divided by b. So this is the opposite of c, same work, the opposite of c divided by b, okay? So if you were to actually do this, solve bx plus c using this process, you would always wind up with the phase shift. So your starting point is the phase shift. So I want to make that clear. When we graph, you're going to start at, initially it was 0, but now we're starting at the phase shift of negative pi over 4. So the phase shift, where you start the graph. Over here is actually the phase shift, which is negative pi over 4, plus the period. If you take the phase shift and you add pi is the length of the wave, you will get 3 pi over 4. So the number on the right side will always be phase shift plus period. Okay? So your x values will start at the phase shift, and they will end at whatever the phase shift was plus the period. Okay, so now we have everything we need to graph. We have the amplitude, and so on and so on and so on. All right, so now instead of starting at 0, we start at the phase shift. So I'm going to call this negative pi over 4. That's my phase shift. That's where we're going to start our graph. And then we're going to end at pi over 4, 2 pi over 4, so I'm going to write that here, 2 pi over 4, which of course is pi over 2, and then 3 pi over 4. Okay, we're going to start at negative pi over 4 and end at 3 pi over 4, and it is a sine function. So we start on the x-axis. We're going to go up to 3 because it's positive 3 just like before, down to pi over 4, down to negative 3, up to 3 pi over 4, and we make our sketch. And just to remind you that some of your math teachers next in the future, all right, that is one full period of the graph, but most math teachers, not me, but most, want you to graph 1 or 2 full waves. So you could continue that and make 2 full waves. But from here to there, 1 full sine wave. All right, so you're going to have a graded assignment. So just to be clear, you're going to label 5 exact values on the x-axis. Check. And you're going to label the y-axis. It's already labeled for you. So you have plotted 1, 2, 3, 4, 5 points. You're going to get graded on, did you plot 5 exact points? Yes. Did you label the x-axis at 5 critical locations? Yes. And you can stick a 0 in there. Bow. Understood. You don't need to label that, but it's nice. And then that's it. And of course the arrows are nice so that you know the domain and you know the range. example 1 done. Skirt to the next problem. All right, so here we go. This one's going to be a little bit trickier because it's cosine, and you'll see what's going on with the x values. It's going to be a little bit more involved. So the absolute value of A is my amplitude. Absolute value of 2 is 2. The period is 2 pi over the B value. So here's my period. Here's my amplitude. Of course, I'm moving faster because at this point we are experts at amplitude and period. And then the phase shift is the opposite of C. So C is understood to be negative pi. So the opposite is pi over our B value, which is 3. So my phase shift is pi over 3. So once again, because you're subtracting within the function, that's going to actually shift my graph to the right. In the last example, we were adding, therefore the graph started to the left. Okay, so we set our argument. Okay, and here's where, ooh, that wasn't good. So here's where you've got to be careful. This is going to determine where we start the graph and where we end the graph. Initially, we started at 0 and 2 pi, but now we're going to shift the graph to the right. Man. Okay, so that's pi less than or equal to 3x less than or equal to 3 pi, and then divide everything by 3. So you compress, take 1/3 of the graph. Okay, so now we're going to start the graph at pi over 3. Now pi over 3 is my phase shift, once again. And we're going to end at pi. Now pi happens to be pi over 3 plus the period. So pi over 3 plus 2 pi over 3 is pi. Begin, end the graph, and then label everything in between that's relevant. Okay, so that takes us to the graph. So we have 0, 0, pi over 3. Goodness. Okay, so pi over 3. Ooh, I gotta quit sitting on the graph here. Pi over 3, 2 pi over 3, and then 3 pi over 3 is here. Now here is the first time where we didn't just automatically, numerically have 5 exact x values. We're going to start here at this x value. We're going to end at this x value. So that means we need to cut that in half, so we're in the middle here. But now we need to find and label this x value and this x value. Okay, and this is what I told you about in class and mentioned this in other videos. This is where you're going to have to be careful. This is where you're going to have to find the midpoint of 2 x values and then find another midpoint of 2 x values. Okay, so conceptually, so let me go to another slide and just talk conceptually. What is halfway between 1 and 7? All right, and you can just count the spaces. Halfway between 1 and 7 is 4. Okay, but numerically, you can find that as 1 plus 7. You can find that as 1 plus 7 divided by 2, which is 8 over 2, which is 4. Similarly, if you make a 70 on a test and then you make an 80 on a test, you know the average of 70 and 80 is 75. Well, 70 plus 80 is 150, divided by 2 is 75. So the average of any two numbers, if it's just two numbers and they're equally weighted, the average of two numbers is just the number in the middle. So for this problem, I need to find the exact value of what's between pi over 4 and 2 pi over 3 and 2 pi over 3. So let's go back to that screen. So pi over 3 plus 2 pi over 3 divided by 2. Now, you don't have to do this if you can find the value without doing this work, but that's going to always give you the midpoint. Okay, so pi over 3 plus 2 pi over 3 is just pi, so therefore pi over 2. So this becomes 1 pi over 3 plus 2 pi over 3, which is 3 pi over 3, pi over 2. So my first label is pi over 2. Okay, so now we need to find the exact value between 2 pi over 3 and pi. And once again, there are numerical shortcuts for that, but this method, 2 pi over 3 plus pi over 2. Okay, so 2 pi over 3 plus pi is 5 pi over 3 over 2. Anytime you divide a fraction by 2, you are going to double the denominator, which gives me exactly 5 pi over 6. Okay? And that takes me to 5 pi over 6. So, have to label 5 exact values on the x-axis. Okay? Now, it's a cosine function, which means initially it started up at 2. So, at pi over 3, you're going to start up at 2. Then you're going to go down to the x-axis, down to the midpoint here at 2 pi over 3, back up, and like this. Okay, so one full period of the graph. And remember, you can find more using the pattern. Okay, but I'm concerned with one full period. Okay, so cosine is down, up, down. Okay, so did you plot 5 exact points? Yes. Did you label 5 values on the x-axis? Yes. And then that's it. You got your graph. Bow, full credit. Okay. Now, so if you're given the equation in terms of A, B, C, we'll do D in a minute, you can graph the function. If you're given enough information to find A, B, and C, can you write an equation? Of course. So let's write this equation in terms of sine. So you have y equals the amplitude times sine of. So to find B, you know the period is 2 pi over B. Okay, and the period was given as 3 pi. Okay, so 2 pi over B is going to equal the period, which is 3 pi. Swap like we did last week. So this is a quick review. 2/3. So we have 2/3 x. Okay, and then now you need, so we have our period. Now negative c over b is our phase shift, which is given to be 6. We have to find b first, which we already found. So negative c over 2/3 equals 6. Now here's where you got to be careful. You've been doing all kinds of tricks and shortcuts. We are not changing this from dividing to multiplying. What we are doing is the opposite of division is multiplying. So if you multiply this side of the equation by 2/3, you have to multiply this side of the equation by 2/3. Let me write that again. That looks terrible. So you're going to multiply by 2/3. Okay, so the opposite of dividing by 2/3, multiplying by 2/3 to solve for, in this case, the opposite of c. 6 times 2/3 is 12 over 3 or 4. PowerPoint is not liking my marker today. So 12 over 3 is 4. Invert. So c is negative 4. So remember, if c is negative 4, then c is exactly what it is. So you write minus 4, final answer. Okay, amplitude is 4. Now if the amplitude is 4, then this value is the absolute value. So you could put 4 or negative 4 here. You found b, And then if you know B and the phase shift, you can find C. Okay? And there'll be a few problems like that to practice. All right, now, 2 more graphs involving midline. So now we have A, which is understood to be 1, B, which is 3, C, which is negative pi, and D, which is 1. Okay, so the first thing you want to find is your amplitude, and your amplitude is understood to be the absolute value of A, which is 1. Okay? So to find the period, 2 pi over 3. So that's our period. To find our phase shift, the phase shift is the opposite of C over B. The opposite of C is pi over 3. So we have our phase shift. Okay? So find the amplitude, find the period, find the phase shift. Right? Now the midline is always y equals d. So the midline is just y equals 1. So we have all 4 characteristics. But once again, we set the argument between 0 and 2 pi. Okay? Now, once again, you don't have to do this to graph. You can graph without finding this, but this is actually how we're going to conceptualize tangent and cotangent. So it's just kind of nice to get into the habit of solving these complex inequalities. All right, divide by 3. Same numbers from a minute ago. Pi over 3, x, and pi. So the nice thing about this graph is I'm going to dive straight in, not getting bogged down in finding those points just because we did that a minute ago. Pi over 3, 2 pi over 3, pi. This was 3 pi over 2. And this value was 5 pi over 6. So let me just reiterate. To get full credit when you graph, you must label 5 exact values on the x-axis. This is the sine function, but you have a midline now. So the midline is here. The midline is the equation y equals 1. It is a line. So now where sine was initially at the origin, now it's been shifted over pi over 3. So over pi over 3 and up 1. So now this is my starting point. And then halfway, and then here. So those are 3 exact points. Same sine function as before, but it's been shifted to the right and up 1. Okay? Now, because the amplitude is 1, that means I go up 1 space and down 1 space. And then, of course, you can continue that if you choose. Some teachers will require that in the future. I just think for the sake of the concept, what matters is 1 full period of the graph. Something else I wanted to say. Oh, yes. So now you think of how far up you go in terms of the y-axis as you start up at 1. So you start at that d value, and then you add whatever a is. So if a had been 4, then you would start at 1, and you would go up 4 spaces to 5. So now instead of starting at 0 and just now that, so to be more clear, the range is not only in terms of a. Okay, so let's actually write that out. The domain, of course, is all real numbers or negative infinity to infinity. But the range The range is now the d value plus a, which is 2, and the d value minus a, which is 1 minus 1, which is 0. And you notice the graph will go down to 0 and up to 2 over and over. So just to generalize that, it will always be, the range will always be the d value plus whatever the absolute value of a is, okay? And it will always be d minus whatever the absolute value of a is, okay? Before it was just the absolute value of a, make it negative, the absolute value of a, make it positive. It was just 3, negative 3, but now it's the midline value. So this is, in general, for all functions in terms of d and a. And then this is the range of this particular function. All right, so to our last example. And at this point, this is going, pretty smoothly. So the amplitude is 1, understood. 2 pi over 2, or pi, is our period. We have our amplitude. Getting a little lazy on those last couple slides. That's all right. We're blasting through this at this point. Our phase shift is going to be the opposite of c, the opposite of pi over 2. So the opposite of pi over 2 is our phase shift. And then y equals negative 2 is our midline. And once again, to be clear, somebody's going to miss points on this and think it's petty. The midline is a line, so it's not a number. Be careful. So on the quiz, when you graph and you get graded for the graph, when you're asked to find the midline, don't just write negative 2. It is y equals negative 2. It's a line. So be careful with that. Okay? All right. So let's find the boundaries of our one full period. Subtract pi. So that gives me negative pi and pi. Divide by 2. And we are going to start at negative pi over 2 and end at pi over 2 for the cosine function. All right, to the graph. Bloop. So we're going to end at, now, I'm going to actually walk 2 spaces this way. Completely up to you how you space this out. You can squash it all into one little space. But I'm going to go negative pi over 2 here and pi over 2 here, just because, PowerPoint, work with me now. So negative pi over 2, pi over 2. And the only reason I did that was those are equal distances from 0. So if I go 2 this way and 2 that way, then I'll have my 4 exact values. What's halfway between pi over 2 and 0? It's pi over 4. So the trick I showed you a minute ago, you only have to use that if you don't know what the midpoint is. And you don't even have to show that work. That was just me showing you how to find the midpoint of any 2 values. It's the average. Okay, so this is a cosine function, but before I do that, be really careful because start with the midline, right? So your midline is the line where y is always negative 2. So your midline is y equals negative 2. And then you're going to plot your exact points. So your graph starts at negative pi over 2, but it's cosine, right? So cosine is 1 space up on the x-axis, 1 space down on the x-axis, 1 space up. Now once again, that's because a is 1. So if I were here and a were 3, from the midline, I would go up 3 spaces. We'll see that in class. We're going to do multiple presentations, like always. So then you graph 1 full period. Try to make it not a V. Try to make it a nice smooth curve. And then, of course, you can continue that curve in both directions if you choose. Boom arrow, boom arrow. Here's my one full period. My cosine function. All right, guys. Bow. Just at 30 minutes, not bad. So you can graph a sine function, cosine function in terms of A, B, C, and D. C was our emphasis. C is going to actually shift the function left or right, and it's affected by B as well. And then, of course, D is your midline value. So y equals D is your midline, and that's going to shift your graph up or down. That's going to shift your graph left or right. All right. Have a great day. Be safe.